Hi guys, and welcome to this, our video on classifying and displaying categorical data. I'm really worried I just said our video. It's only me, but there are a number of people living in my head, I'm sure. My name's Darren from Maffs Guru, really good to see you. I'll go through the content in just a moment. If you can subscribe to my YouTube channel, please do so. It just lets me know that you're watching. Very small click from you, massive impact for me. And sign up on TikTok and Instagram and all those type of things if you can. Alrighty, enough of that rubbish. What are we dealing with today? Data is massive. This is such a big part of the course. It is huge, right? When you get to year 12 general maths, trust me, it is a huge section of the course. So trying to get it right now is going to save you hours of pain later on. And it's all in the language. There's a lot of language in this particular thing. So what are we going to look at? We're going to look at basically the idea that data can be classified as categorical or numerical, and that categorical and numerical data can then be subclassified as either nominal and ordinal or discrete or continuous. And being able to find out what they are is really important. There are questions in the VCE exam every single year that try and trick people with their understanding. And there are tricks to this, trust me. Be able to do frequency and bar charts and all those type of things and interpret them is really, really important. And when I say interpret, what I actually mean is, although this is maths, you're going to have to write sentences. You're going to have to actually tell the examiner you understand what a bar chart or a histogram or a frequency chart is actually showing you, right? So don't just think it's just all numbers. It really isn't. And sadly, that's where lots of people get tripped over. Now, as I say here, while this is the first lesson of this particular section of the course, and there are quite a lot of lessons coming up, it is critically important. So have your summary book next to you. A really good summary book will save you hours and hours and hours and hours of hurt. And what I say is, you put in your summary book what you will never remember. All right, so you put in your summary book those things you can't remember. Don't just recreate a textbook. That doesn't make any sense, right? You may as well take the textbook in. Put in the summary book the stuff you literally cannot remember, and then you're going to end up with a good summary book. All right, now data is all around us, and we have to be able to analyze it. So let's imagine I've been doing some sort of a survey, and I've gone out and I've said, hey, can you tell me your gender, please? That gets a little bit all contentious at the moment. What coffee do you drink? What coffee size do you have? No judgment, really. How many brothers do you have? Weirdly, I don't seem to be interested in numbers of sisters. And can I just have your hand span? Now, I'm not really sure what this survey is actually trying to find out because I don't quite know how to link gender, coffee size, number of brothers and hand span. But if you can, leave some comments in. No, I don't think you would either. All right, but the point of it is, when we look at this data, we notice that some of them have words or letters. Others seem to have numbers. And in previous years, I'd have turned around and said, oh, guys, anything with numbers in it is numerical, anything with words in it is categorical, and undoubtedly most of my students would have done very poorly in trick questions. But we can see for now, there is 4 columns of data. Yes, there's gender, coffee size, number of brothers, and hand span. Now, categorical data is a bit of a trick, all right? And as I said, in previous years, I'd have said anything with a word in it is categorical. That's not necessarily true, and VCAR tricked people up. If this particular year and last year, the exam I think was a little unfair, but we're moving on. What we notice here is that we can put people into categories, all right? So in this situation, if we look at gender, we are categorizing people as male or female, right? Now that there is categorical data, right? We're choosing a category in which to put people. Coffee size, large, small. Obviously, they could have had a medium, although apparently not at Starbucks because you have to have a tall, a grande, or a super grande. That's ridiculous. Anyway, so categorical data is where we put people in several or categories, yes? Now, the first 2 columns are categorical. And we can split categorical data further, right? So once we've allocated the idea, once we know the idea that something is categorical, we then need to try and work out, well, is it nominal or ordinal? Now, nominal, as I say here, if I look at the word nominal, it begins with the word no. Now, what that means is that there is no order. I can't put the categories in any particular order. And so, for example, if I look here at gender, is male and female able to be placed in some sort of logical order? Are males more important than females? Hold on a minute. Whoa. Are females more important than males? Well, according to Beyonce, yes. But the point of it is, there is no implied order there. So there is no order, it is nominal. So I would describe that as categorical and nominal. What about coffee size? Well, coffee size, small and large, because of the way we've structured the English language, we know that there is some implication there about an order. I would be able to order my coffee cups small, medium or large, medium or small, depending on what I decide to do. So in this situation here, that column there is definitely categorical, but it is now ordinal, ordinal. And how do I remember that? Ord for order. There is an order. Okay, so again, now we should be in a situation where I've got some questions coming up that I should be able to say, well, is that categorical? Is it nominal? Is it ordinal? Can I put it in an order? Now, there are other examples of categorical data, lots and lots of them, and I put these in your summary book. All right, it's not an exhaustive list, and every time you come across a new one in a question, write it in your summary book. There are some tricks here though. So, colours. We can't place colours in an order. Political parties, we can't place those in an order. Now, postcodes, huge trick. You're going to say, hold on a minute, postcodes have numbers. They do have numbers, but there is absolutely no order to them whatsoever. And, believe it or not, I can't have an average postcode. Now, I'm going to talk about that in just a moment, but for numbers, if I look at heights and weights and times and all that type of stuff, I can work out an average height. That makes sense. I can add all those numbers together, divide them, and I'm going to get an average height. I can get an average time, get an average weight. What on earth would an average postcode mean? If I added up all the postcodes where you live and divide by how many people there are, it doesn't mean anything, all right? So postcodes, believe it or not, are categorical. And now if I asked you, are they nominal or ordinal, you'd go ordinal, wouldn't you? Because numbers, sadly not. Postcodes are actually nominal because there's no real order to postcodes. If you look at a map of postcodes, there's not an order. It's not like they start from left and go right or round and round. So that's a bit of a trick. Years, huge one here. VCAR, really for the last 2 years have upset a lot of people here. But years are actually categorical data, depending on the context of the question. But please realize that for now, years are categorical. Running numbers on jerseys. All right, or so if I was to do the marathon and have the number 1,406, doesn't mean anything. It's categorical data. I've just been given a number. I can't have the average jersey number. It doesn't make any sense. It doesn't relate to how fast I'm going or where I'm going to finish. It's just a number. So in that situation, it's categorical data. All right. Telephone numbers. Again, it might have numbers in it, but shoe sizes, believe it or not, you can't have an average shoe size. It doesn't make any sense. Right? Shoe sizes, we've chosen numbers, but just because it was convenient to do so. All right, so as I say here, and I've talked a lot about this, but it is so important. To be able to decide if something is categorical, ask yourself the question, can I work out the mean, median, range, or mode of the data? And if I can, will that number make sense? So as I say, if I added all the postcodes together, yes, they're numbers. I can put them in my calculator, 3,000 plus 3,001 plus 3,002. When I add them together and divide, does it mean anything? Is there an average postcode? It doesn't make any sense, right? So just put that in your summary book and make sure that you understand. Now, obviously then there is numerical data. Ooh, numerical data is something that can generally be counted or measured. So for example, if we look here, number of brothers, can I count the number of brothers I've got? Absolutely. Or the number of brothers people have? Yes. Can I measure a handspan? Absolutely. Now, a word of warning here, handspan, you'll notice there are decimal values. You'll notice that there are decimal values, right? My handspan, I've rounded it to 23.6, right? I've rounded it because maybe that's as far as I can get with the ruler that I've got, that I've had in my pencil case since 1937, and it's all a bit manky. I can measure my handspan much more accurately than that. I could have a lot more decimal places if I had a really technical piece of equipment, but I don't. So handspan can be to many, many different decimal places, to one decimal place. It could even be to a nearest whole number, but it is still numerical data. So we've got numerical data. It's anything that can be counted or can be measured. What about discrete? So numerical data can be subclassified. discrete. Now, in this situation, discrete basically means it can take predefined whole numbers, generally speaking, all right? So it takes whole number values. All right, so the number of brothers, I can't have 2.3 brothers. I mean, that again wouldn't make any sense. So discrete data, generally speaking, whole number. So here, that there would be discrete data because I can't get a decimal place in it. And then we move on to continuous data. What on earth is continuous data? Well, it would make sense then that it's something that can be measured, something that can have decimal places to it. Usain Bolt, right? He's run the fastest 100 meters, I think it is, yeah. I think his time is rounded to 3 decimal places, I believe. Actually, no, that's the quickest we can measure. But there are many more decimal places that could come, all right? We've just chosen to do it to 3 decimal places. In this situation, we've measured my hand span in centimeters to 1 decimal places. So because it's measured, this here would be continuous data. All right, so what we've got categorical and numerical, and then inside of that is nominal and ordinal, and discrete and continuous. All right, so here's an example. Classify the following variables as categorical or numerical. Students choose their favorite pet from dog, cat, bird, or other. Numerical? I don't think so. Categorical? Absolutely. So that one there, I'm going to put C for categorical. The time in seconds taken to solve a puzzle is recorded. All right, so that's been measured. All right, time is measured. Someone stood there with a stopwatch or however, and so in which case that there would have to be numerical. Now, a fairly simple example, I know, but trust me, they get a lot harder. Classify the following variables as nominal or ordinal. Now remember, nominal, no order, or ordinal has an order. A group of people record their level of happiness as very happy, happy, not too happy, or very happy. Now again, because the way the English language is structured, if we saw that in a survey, we would know that there would be some sort of order to that one there. So in which case, I'm going to say that is ordinal. Students select their favorite country to visit. Country. Country is, can I put them in order? Is Australia more important than New Zealand? Oh, again, not getting into that one there. But again, in that situation, that would be nominal because we can't put country names in any sort of order. Classify the following numerical variables as discrete or continuous. All right, so okay, right. The number of children in a family is recorded for all the students in a school. Well, I can't have 4.7 children. Okay, it doesn't make any sense. Might be able to have that as an average, but in this situation, the number of children recorded would in that situation be discrete because it's whole number. It's going to take a whole number. It's been counted. The birth weight of babies measured in grams is recorded at a hospital. Weight, again, in this situation, weight is measured. You put it in a scale. That scale can go to all sorts of decimal places. And so in that situation, I'm going to say that there is continuous. More. Classify the following numerical variables as nominal, ordinal, discrete, or continuous. Now, in this situation here, we'd be looking at using 2 of them. All right, so let's see. Or is there 2 of them? The number of students in each of 10 classes is counted. The number of students is counted. All right, so that's counted, in which case that's going to be discrete data. The time taken for 20 mice to each complete a maze. Time. Time is one of those things that's measured using a stopwatch. If it's measured, it can go to decimal places. That would have to be continuous. Okay, now moving on to the next one. Diners at a restaurant were asked to rate how they felt about their meal. 1, very satisfied. 2, satisfied. 3, indifferent. 4, dissatisfied. 5, very dissatisfied. Now, a lot of people who will get tricked and they go, it's discrete because there's numbers, yeah? But no, we've just basically given very satisfied the number 1. Like going back to the jersey again, we've just given that very satisfied is a 1. We didn't count it. We didn't count 1, 2, 3. In fact, you can't count that. It's just been given. So in that situation, it is going to be ordinal. The reason it's ordinal is because we can place those in an order by 1, 2, 3, 4, and 5. Likewise, students choose a color from a list. 1, 2, 3, 4, blue, green, red, or yellow. Now in this situation, again, those numbers don't mean anything. I haven't counted them. I've just let blue be the number 1. So realistically, we're looking at the blue, the green, the red, or the yellow. So in that situation, that would have to be nominal, yes, because there is no order to those colors. Students' heights were classified as less than 160, 160 to 180, or more than 180. Now again, people think that that's actually discrete or continuous data. They think that's numerical data. It actually isn't. Although it's got numbers in it, it's a group of numbers, right? So I can't do anything with that group of numbers, and as such, it becomes continuous data. Because it's continuous, that means I can only choose whether it's nominal or ordinal. Is there an order to this? Is less than 160, 160 to 180, and more than 180? Can I put that in an order? Does English allow me to order that? Absolutely. So in that situation, this here would be ordinal. Now, again, this stuff takes practice and discussion. You're going to get some of them wrong, but it's really, really funky stuff. Now, the reason we do this is we also want to be able to turn words into pictures. We like pictures. Pictures are amazing. Our brain loves drawing pictures, right? So, the great thing here from the Cambridge textbook is categorical data can be summarized in a frequency table or percentage frequency table. A frequency table can be displayed in a bar chart. A percentage frequency table can be displayed in a percentage bar chart. So if you put that in your summary book, it's giving you an idea of how to do something with categorical data. Frequency table, and then we can turn that frequency table into a bar chart, which is pretty much what we're going to do here. A frequency table is a table where we work out the frequencies of each of the categories. Right, so we've got an example here. 30 children. Choose sandwich, salad, or pie. So we've got sandwich, salad, or pie. Those are my choices. Construct a table for the data showing both frequency and percentage frequency. All right. So first things first, I'm going to draw my table, and I'm going to write frequency, and I'm going to write percentage frequency, because I'm going to work out what my frequency are first. Now, obviously, when you do this, please, 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 please use a ruler. Okay, that's going to be critically important. Now, what I'm going to do now is I'm going to work out how many people had a sandwich. Now, when I work through the data, every time I see sandwich, I'm going to cross it through. 1, 2, 3, 4, 5, 6, 7 people have a sandwich, right? So there are 7 people have a sandwich. Now, you're probably screaming at me going, no, you missed one, you missed one. We'll see. What about a salad? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people had a salad. Now, how am I going to pick up if I've made a mistake? Well, when I add all these numbers together, that bottom number that should go in here won't be 30, right? They told me there's 30 people, so let's now see pie. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now, when I add all those values down in that column, I get 17, 30. So actually, awesome, I haven't made a mistake. And crossing off those numbers is a really, really good hint, all right? Or a really good thing to be able to do, simply because you're not going to make mistakes. Lots of people just read through it and then they make mistakes and it all goes horribly wrong. So there we go. So now I've got my frequencies. I've got a column of frequencies. But I also want my percentage frequency. So my percentage frequency is calculated by taking each individual frequency and dividing by the total number of frequency, or the total of the frequencies, and I'm going to times that by 100. So for example, that one in there, I've got a frequency of 7. I'm going to divide it by my total of 30 and times it by 100 to turn it into a percentage. Now, how am I going to do that? I'm going to fire up my TI Inspire. So doing that, let's close that one down. Yep. Oh no, cancel. Let's close it down and do no. And open up a new calculator screen. So what do I want? 7 divided by 30. I want to times that by 100, if you would please. It gives me 70 on 3. That's no use to man nor beast, is it? Now, that's because my calculator is in exact mode. So what I'm going to do is I'm going to go home, settings, document settings, turn it from auto into approximate. That therefore will give me all of my answers in decimals. Let's go back and copy that down, and there we go. Now we get 23.33%. So I'm going to put that down as 23.33%. What about salad? Well, that's 10. So in that situation, I'm going to do 10 on 30. times 100 gives me 33.33, 33.33%. And then my pi is going to be 13 on 30 times 100, which gives me 43.33. Now, when I add all those together, believe it or not, I'm not going to get 100. I'm going to get 99.99, but pretty close because we've just got a small rounding error in there. So there we go. So there is my 100%. I've got my table of information. What does it want me to do now? Well, it says construct a table for the data showing both frequency and percentage frequency. Ka-ching! Now, having got that table, and in many cases, sometimes that's just going to be awesome. Thank you very much. I'm done. You may want to be asked to draw that in some sort of graphical way. And bar charts are used. Now, bar charts have gaps. Please notice, bar charts have gaps. But when we have a bar chart, all right, it is important that you copy this into your summary book. All right, so frequency or percentage frequency is shown on the vertical axis. So in this situation here, if I was going to be drawing a bar chart of my frequency, then up the side, I would have frequency written aside. The variable being displayed is plotted on the horizontal axis. Now in that situation, because we are dealing with lunch choices, we would effectively have sandwich, salad and pie along the bottom. The height of the bar gives the frequency. The bars are drawn with gaps to indicate that each value is a separate category, and there is one bar for each category. So for example, if I was going to be drawing this, I've got to go up to 13, 2, 4, 6, 8, 10, 12, 14. There we go. So I've decided to go up in twos simply because I can. Now, when you're doing this, please, please, please make sure you use a pencil and a ruler. VCAR will mark you down if you do not use pencil and ruler for diagrams. Don't draw in pen. And if you don't have a pencil with you, really sorry, that's on you. Get a pencil, get 4 pencils, put them in your pencil case and get into the habit today of using them. Don't leave it until next year because you'll forget. You'll do your graph in pen and VCAR will go, nah, you're wrong, and then you lose more marks than you do. There are 3 bars. So I'm going to do 1 bar here, 1 bar here, and 1 bar here. Now what you notice is each of those widths are equal. So that's going to be sandwich, so I'm going to write sandwich. That is going to be salad, so I'm going to write salad, and that's going to write pie. Now obviously I'm very scrunched for space here, but you will be able to draw it bigger and write all the word sandwich, all the word salad, and all the word pie. So salad, sandwich in that situation will go to 7. So I'd go up to 7, I'd go down, and again, you have to do this properly. You don't need to shade them in, I just do that because I can, but you would have to make sure that line sat exactly on 7. And again, I know that people previously have gone, oh, it's close to 7. VCAR aren't interested in close to 7, right? They'll give you lines to draw on. You must draw on the line 7. So what have we got here? Salad was 10, roughly speaking, and I mean very rough, and pie is going to be 13. And there we go. So that there would be my bar chart for frequencies. Could I do percentage frequencies? Absolutely, because I got my percentages there. The only thing that would change is that the vertical line would be percentage frequency. Right, use the frequency table for lunch choices from this example to construct a bar chart. Well, I've just done that. So again, if I was going to do that, I would draw my lines. I'd have my scale 2, 4, 6, 8, 10, 12, 14. And I would do, my first bar would go up to 7, wasn't it? Yep. My next bar would go to 10. And my next bar would go to 13. And again, this is really rough. You guys have the opportunity to be able to do this, right? So this would be lunch choice along here. Don't forget to label your X's. This would be just frequency because we're doing a bar chart, as in a frequency bar chart. Here would be sandwich, here would be salad, and here would be pie, and ka-ching, you are done. If I want to do a percentage bar chart, exactly the same idea. Right, so here I would have lunch choice. Here though, I would have percentage frequency. And what is my percentages? Well, the highest seems to go to 43. So I go 10, 20, 30, 40, 50 in this situation. 50, 40, 30, 20, 10. And again, it's important to notice that my scale goes up equally up the side. If it doesn't on your graph, again, you'll be in all sorts of trouble. My lunch choices stay the same with my 3 bars with gaps. You've got to have gaps. So we'd have sandwich, we'd have salad, and we'd have pie. So my sandwich would be 23.3%. So that's roughly speaking there. My salad would be 33.3%, would be roughly speaking there. And my pie would be 43.3%, which would be roughly speaking there. And that got spectacularly close to touching that bar with no gap. Whew, I'd have lost my marks. The last part of this video talks about mode or modal category. Now again, categories are the words. These are my categories here: sandwich, salad, or pie. And the mode is the most common, the highest bar in there or the biggest number. Now, sadly, a lot of people make silly mistakes here, because when they say, what is the mode or modal category, a lot of people will put the number down. They'll put the height of the bar down, or they'll read the number from the table. Please don't do that. That's not what it's asking for. It wants the modal category. So in this situation, I would know that my modal category for my data here wouldn't be 13, but that 13 tells me that the category, which is the word or whatever I have in that column there, would be pie. So in that situation, I would say my modal category is equal to pie. There were the most pies, right? Most, mode, use that, right? So again, don't get tricked on this type of thing. Why do we use the mode? Well, we use it to be able to make judgments and inform on how close things are. Now, obviously mode, in this situation, if I know that pies are really important this week, then I probably find out that pies are going to be important next week, right? So I'm probably, if I'm running a kitchen, will want to order more pies. Supermarkets do this with ice cream. They look at the weather, they look at customer trends, they look at the time of the year, and that helps them work out, you know, which of the brands or which of the ice cream flavors they want to get, right? But it's also very important that when we have the mode and the median, this is coming up a bit later on, that we can actually decide whether data is symmetrical or skewed. Using words I haven't even introduced yet. That's okay. But we're at the end of this particular video. Thanks very much for watching. It's a long one, 28 minutes nearly. Whoa, but there's a lot of information in this one. But if you didn't understand it, go back, watch it again. Highlight the sections that you need to. Copy into your summary book what you need, because the whole idea of continuous, numerical, discrete, all that type of stuff is very, very important. But I'm done. Thank you very much for watching. Please subscribe if you can. Otherwise, I look forward to seeing you in another video. Bye-bye.